Welcome back to the deep dive. Today we're swapping the geopolitical landscape for something a little more, well, a little more earthy. We're doing a deep dive into the surprisingly complex world of potting soil.
Yes.
Specifically, what happens when you push it to its absolute limit. We're talking about the heavy, unceasing stress of monsoon rainfall.
It's a fantastic pivot, because I think even experienced gardeners can take potting mix for granted. They just assume, well, soil is soil.
Right.
And our sources today, they really challenge that idea. We're pulling some fascinating details from part 362 of Notes on Gardening.
Okay.
It's a really detailed account of observations the author made right as they were entering the final 2 months of the year. So that's when the monsoon season really hits.
And that context is just everything, isn't it? When you go from, watering with a can where you control everything.
Right, control the volume.
To an actual deluge where nature just takes over. Suddenly the whole equation shifts. Drainage isn't just a nice to have anymore. It becomes the one thing that decides if your plants live or if they drown.
Exactly. And the author had been routinely watering these 3 different potting mixes with tap water long before the monsoon arrived. So this wasn't a fresh test.
So they were already sort of fatigued.
Yes, fatigued and settled by daily care. That's the key.
Okay, so let's unpack this. Our mission here is to analyze the visual evidence from the source. We've got 3 main contenders: a clay-heavy mix, a quality compost mix, and a pure cocopeat mix.
3 very common types.
And we want to see which one structurally handled the sheer volume and force of a real downpour, and more importantly, what that tells us about long-term plant health.
And the visual outcomes are, they're astonishingly clear. You can literally see the success and the failure just by looking at the surface of the soil.
Let's start there then. Let's start with the visual loser, the one that failed most spectacularly. And for reasons that might surprise you if you're just, buying a bag of soil at the store. This mix was sold as black soil, but it was actually something else.
It was primarily clay soil coated with ashes. A bit of a deception, really.
And what really stands out on the notes here is how the failure was a process. It wasn't just a sudden event, was it?
No, not at all. See, clay is made of these very, very fine, flat particles.
Right.
And when you consistently water it, especially with the force of tap water, those tiny particles they settle together. They get tighter and tighter. This is the mechanism of compaction.
So the repeated watering is basically turning the mix into pottery before it even gets baked.
That's a perfect analogy, yes. The water acts like a cement, pulling those particles down, squeezing out all the air pockets that the roots desperately need.
So by the time the heavy rain hit, this mix was already in big trouble.
It was severely compromised.
And what was the immediate result? What did the author see when the monsoon finally arrived?
A catastrophic failure. The source notes the drainage was, and I'm quoting here, sluggish to non-existent.
Wow.
The clearest observation was a fully flooded surface in the plastic cup it was in. He described it as looking like a small, sad, still pond.
You can just picture that. A thick, soupy layer sitting on top. It's a vital lesson, isn't it? If your water can't move through the soil,
Then the roots get no oxygen.
yeah.
You've created an anaerobic environment, a water prison.
A water prison. I like that. And that surface flooding just shows that drainage is way more than just preventing overwatering. It's about air.
It's about that essential air exchange for root respiration.
Yeah.
Clay compaction just seals the whole system off.
Okay, so we have a total structural failure with the clay ash mix. But now let's move to the second sample, the quality mix. Here we find a partial failure, which raises an interesting question. What defines failure when you go from catastrophic to just compromise?
Right. This second sample was a proper compost soil mix with some perlite included.
So this is what you'd expect to be a good baseline.
Exactly. Rich in organic matter, better structure than clay, and that perlite is there to add permanent air pockets. It definitely performed better than the clay mix.
But there was still a problem under heavy rain.
Yes. While it didn't flood catastrophically, the notes mentioned it still retained some water on the surface.
So what did that look like?
The drainage was just slow. So unlike the big static pool on the clay, the compost mix might have shown smaller temporary puddles, or just a shiny, oversaturated sheen that took a lot longer to absorb.
And why does a quality compost mix still suffer from this?
Because organic matter breaks down. That's the thing. Unlike the mineral structure of clay, Compost is constantly decomposing, settling, collapsing on itself.
So that prior consistent tap watering had already started breaking down the structure.
It accelerated the degradation.
Yeah.
Exactly. So while the initial structure was good, the constant saturation just reduced the size and number of those vital air pockets over time.
So what we're seeing isn't a fundamental design flaw like the clay, but more a slow, inevitable structural compromise, a failure of longevity.
Precisely. It just confirms that all potting mixes, even the really good ones, are temporary structures. They are all prone to some compaction over months of use. You just can't escape the physics of it.
Okay, now this is where the observations get really interesting for me. We move to the third mix, which, by the metric of drainage speed, looked like the golden child.
It did.
The cocopeat mix with coco fiber.
And initially, its performance was just stunning. The author noted it had extremely high drainage.
So while the others were puddling, this one was clear.
The water just vanished from the surface of the coco-peat mix. I mean, if you were judging purely on preventing surface pooling during a storm, this mix won, hands down.
It seems like the perfect solution then. Great drainage, lots of aeration for the roots, but the source suggests superior drainage is only partially the right measure. So what's the catch?
The catch is his serious long-term paradox. It's rooted in what coco-peat actually is.
Which is?
It's the pith of the coconut husk. It's super fibrous, structurally irregular.
And that structure is what creates these huge, fast pathways for water to just rush out.
Yes, exactly. The large pores let the water rush right through. That's why the surface clears so fast. But, and this is the crucial part, the individual cocopeat fibers themselves have extremely high capillary action.
So like a sponge.
Each fiber is a tiny sponge, soaking up and holding onto water internally, even as the bulk of the water is rushing past and out the bottom.
Wait, that sounds completely contradictory. If it drains so fast, how can the pot still be too wet? What are we missing just by looking at it?
We're missing the internal state. The surface looks dry, the drainage holes look clear, but internally, the medium is saturated.
So it's the difference between flow and retention.
That's it. You get the quick flow, but you keep a highly saturated sponge inside the pot, holding on to moisture for days.
And that long-term moisture retention is the critical flaw that the author discovered later, right? When reusing these mixes.
Exactly. When the author checked on these mixes later, especially the ones kept in, poorly ventilated plastic containers, the consequence was undeniable.
Mold.
Widespread fungal or mold issues.
And mold in your potting mix is often a death sentence for delicate roots, especially seedlings. It speaks to the health of the entire environment in that pot.
It does. Fungi thrive in places that are both moist and lacking oxygen. So the high internal moisture of the cocopeat combined with the lack of air movement in a solid plastic container, it just creates the perfect breeding ground.
So this raises a really profound question for you, the listener. When you choose a potting medium, are you optimizing just for that speedy drainage during a storm, or are you optimizing for long-term health and stable aeration?
Because the cocopeat mix shows those two goals can be in direct conflict. And that leads us right to the solution that gardeners figured out to solve this exact paradox.
So what does this all mean for the home gardener? If you have this moisture problem in a mix that looks like it's draining fast, the observation itself points to a common fix.
Yes, the standard strategy is to permanently break up that spongy capillary action. Gardeners do this by incorporating perlite into the mix.
Let's clarify what perlite is actually doing, because I think a lot of people just see it as filler.
It is not filler. It is critical. Perlite is essentially puffed volcanic glass. It's inert, so it doesn't absorb water, and, crucially, it doesn't break down or compact.
Okay.
When you mix it in, it physically keeps those cocopeat fibers separated. It creates permanent, non-collapsing air pockets.
So it's not just about creating drainage channels, it's about maintaining structure and airflow after the water has passed through.
Absolutely. It ensures oxygen can get to the inner core of the pot, and the source material actually gives us a little insight into why this step wasn't taken in the experiment.
The detail about the perlite shortage.
Yes, it's so telling. It confirms the author wasn't testing an optimized mix. They were testing the pure properties of cocopeat itself.
If they'd had perlite, the outcome would have been totally different.
The cocopeat mix probably would have performed exceptionally well. The shortage forced a pure material test, and that's what revealed its hidden vulnerability to mold.
Which brings us back to the final and maybe the most crucial conclusion from the source. It moves away from finding one single perfect mix.
The ultimate takeaway is that generalized advice fails under stress. The fundamental principle that gets reinforced here is that different plant species require fundamentally different potting mixes.
That personalization is everything. You just can't treat every plant the same. When you're transplanting a seedling, you have to actively consider what that specific plant needs.
Well, think about the two extremes. You have an orchid, which naturally grows on trees and needs extreme airflow.
Right.
You'd want a mix that's mostly bark and heavy perlite. You're prioritizing drainage and aeration over retention.
And on the other end, maybe a moisture-loving fern.
A fern or a tuber that likes consistently damp soil. For that, a quality compost mix that holds on to water a little longer might actually be ideal, provided, of course, the container itself has great drainage.
Right. You can't put a succulent that hates wet feet into that pure, spongy cocopeat setup and expect it to survive just because the surface cleared quickly.
Understanding the material is step one. Tailoring it to the plant's biology is the actual solution.
This has been a true deep dive into, well, the ground beneath our feet. Let's quickly summarize the 3 key points from Notes on Gardening.
Let's do it.
First, the danger of compacted clay and ash soil. It leads to surface floods and is caused by the cumulative effect of regular watering over time.
Second, the paradox of cocopeat. It looks like it has high drainage, but its internal structure holds on to a ton of moisture, which leads directly to fungal issues in poorly ventilated containers.
And third, the solution. Adding permanent structural components like perlite to ensure aeration. This reinforces the big idea.
Yeah.
The mix must be personalized to the plant.
And that leads to a final provocative thought for you to consider, taking this observation just one step further. We focused a lot on the mix, but the container is just as much a part of the system. So for you to explore further, how much is the choice of the container? Its material, its size, the number of drainage holes, how much is that impacting the health of otherwise perfect potting mix?
Because the soil can only do so much if the vessel itself is a problem.
Exactly. The vessel can be the limiting factor, and that is a whole new deep dive.